Hey physics class, we're back with the second assignment. So let me just open that up and we can get started. So this one has a circuit which still has four resistors, but it's still a little different than the last one. And it just asks for the equivalent resistance of the circuit. So I want to see if I can give you a strategy for how to digest these problems. I was thinking about this, and unfortunately, the the way that physics problems went in the first semester was so simple, comparatively speaking, because it was here's an equation. Let me hide clues to the values of all the variables in a word problem. You have to discover the value of those variables, plug them into the equation, and then find an answer. Compared to these, that was actually very simple because, look, you have a formula for how to add circuits in series, and you have a formula for how to add circuits in parallel. But as for determining how to basically digest a circuit, that's a lot harder. You have to basically interpret this, make sense of how electricity flows through it, and that's hard to do. So obviously I don't need to draw this because it's already on screen in the corner, but there's something I want to do with this second one that might help you with a bunch of others. I'm going to redraw this a couple of times actually in stages, and I want you to see a kind of gradual process that it goes through that keeps certain things the same. So remember that these are all wires, okay? And wires, the shape doesn't matter, the length doesn't matter. All that matters is what is connected to what. So let me redesign this circuit just geometrically, put it in a different shape. Just imagine the wires are flexible and you can move them around. This circuit is functionally identical to this one. So here's resistor 1 again. And at the end, let me just go ahead and stick resistor 4, because I'm going to do the middle last. So here's something that is actually the same. So they might not look obviously the same, but they are. So just so we are clear, this one would be resistor 2, and this one would be resistor 3. So how are these the same? You start out, you must go through resistor 1. Okay? You start out, you must go through resistor 1. Good. After you go through resistor 1, you hit a fork. After you go through resistor 1, you hit a fork. Choose one path of the fork, you go through resistor 2. Choose the other path of the fork, you go through resistor 3. Choose one path of the fork, you go through resistor 2. Choose the other path of the fork, you go through resistor 3. After you go through 2 or 3, you join back up, and then you must go through resistor 4. After you go through 2 or 3, they join back up, and you must go through resistor 4. Do you see the similarity? Okay, so you've got these two resistors that are much closer to each other. What if I were to take those two resistors and just wrap them together in tape? Put them in a package. How are you supposed to tell that that's two resistors from the outside? The point is that you can't. That two resistors in parallel, if they are in a series like this, are behaving as resistors in a series. So a pretty good strategy for solving circuits is to try to identify it as one big series, and then replace resistors in parallel with equivalents to be in that series. So let's go ahead and do that. If you took resistor 2 and resistor 3 and you put them in parallel like that, you'd have to add them up. So you do it like this. 1 divided by. Okay, what are their resistances? Got 4.7 thousand, so 1 over 4,700 plus 1 over 550. 1 over 550. Okay, so we ended up with 492.4. That would be resistance of that. So, looking at this, we've got a 2.2 thousand followed by the equivalent of a single 492.4 followed by an 840. Since they are in series, we add them up just like that. 2.2 thousand plus 492.4 plus 840. You get 3,532.4. 3532.4. 3532.4. There we go. All right. I'll be back with assignment number 3.